Okay, here we go. I'm going to give you a little bit of a crash course in vector basics, things that probably took place at some point in either pre-calculus or some time before you were in calculus. A vector has both magnitude which is length and direction. So we typically talk about them with arrows. We draw arrows on graphs. So say I had the vector equal to 3, 4. Well, what I can do is I can start here at the origin and then go over to the right 3 and up 4, and that lands me here, and draw an arrow like that. Now here's the deal with the vectors. You know, that's it drawn from the origin. I could label it V like that. I could start it here and go over 3 units and up 4 units like that. And that would also be V. It doesn't have a specific starting point. So I can pick this up and move it somewhere else, and it'll still be that vector. So that's the first thing you should know about vectors. They have magnitude and direction, and they can start anywhere, end anywhere. Say I had U equals negative V. Well, that would be negative 3, 4. The negative kind of distributes in. It gives me negative 3, negative 4. So it's probably exactly what you guessed. It's just a backwards version of this vector. So I'm going to go back 3 and down 4 to here. So it'd be like that. So that would be U. I could also do something like draw U from here, back 3, down 4, like that. And that would be U. So it's just, it goes in the opposite direction. A negative vector, if I were to do U plus V, for example, I would get what's called the zero vector. So the next thing that I can do, so I should have said, this is called the component form of a vector. The x component is 3 and the y component is 4. If I were to give you something, go right 3, go up 4, well, that has a length, overall length here, and it has a direction. It's implied by these that combination of the 3 and the 4. I could figure that angle out by using some kind of trigonometry. So let's talk about the length part of it. In your head, what do you think the length of this vector is, and how would I find it? Hopefully you said to yourself, Pythagorean theorem. So the length of V, I indicate it by doing absolute value bars around the V, like that. It says, that's a way of saying magnitude, and it looks like absolute values, but it's not. It says take the magnitude. I'll give you a formula. It's the square root of Vx squared plus Vy squared. So it's just Pythagorean theorem applied to the components of the vector. In this case, 3 is Vx and 4 is Vy. So the length of V in this case is root 3 squared plus 4 squared. That gives me 9 and 16, which has a 25, which square roots. It's a Pythagorean triple. The length of V is 5. So I erased that. I'm going to go on to the next part, but what I will say is that the word magnitude, especially in the Khan Academy that I'm going to give you later related to this, will come up. Anytime you see magnitude, you want to find the length of that thing. You want to apply Pythagorean theorem. All right, so next thing we're going to talk about is scalar multiplication. Oh, oops, I erased V. I want V to be 3, 4. So what would 2V be? Well, that would be 2 times 3, 4. And just like with that negative, it just distributes in. What's twice that vector? Well, it's going to be 6, 8. So what would that look like on this graph? It would look like that. Let's see if I can do this right. Boom. Notice I could also start here and go over 1, 2. Here. And then up. There, I think. Anyway, that would be this. This would be 2v. So, notice it just doubles the length of the vector. If I were to do Pythagorean theorem on that again, I would get a magnitude that would be twice the magnitude. It would be 10. So the last thing I'm going to talk about here is about how to deal with vectors if they're given to us in terms of a length of the vector and an angle. Well, it's pretty quick and simple. The x component, the x component is always the length times the cosine of theta, and the y component is always the length, in this case 10, times the sine of theta. That should make sense from what you know about sines and cosines and hopefully polar coordinate systems from earlier. But in this case, x would be 10 cosine of 150. Y would be 10 sine of 150. So you could plug that into a calculator. One disclaimer, I say in calc we're always in radians. In this case, I used degrees. Sometimes Khan will use degrees in these cases. So be ready for that. Be aware of that. Partially because I'm sending you back to stuff before it was calculus, so that's why these degrees show up, and I'm doing it in degrees here because that's the way you're going to see it in a moment. But we do get this, and we get this. Take note that 150 would give me an angle of 30 down there, so you could do this using special right triangles, which is why this just comes out to be 5. But that's beside the point. This vector that I've drawn, by the way, inaccurately because it's not a height of 5, is negative 8.660, comma 5. So that this would be the component form of the vector that I've drawn here with these properties: length of 10, angle of 150. So I'm going to ask you to do a handful of Khan Academy problems in a moment. And those problems should all go really, really quick. It might look like a long list, but like they should snap, 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 go really fast. And I think you will do well with them. And then a lot of those ideas, the length, stuff like that, they are going to show up later on when I have you do Khan with vector value functions. So, oh, one more thing about Khan. I think this is the first Khan that I'm giving you during this, like, not being at school thing. But one, go through it once. Don't stress out about going through it twice or 3 times. If you get the concept, then we're good to go. Same as it is in class, right? I don't need you to get 100%. If you're really confused, you can watch some of the videos that Khan does so that you can see how to do it. But if once you get through I'm giving everyone the same cons. So while you should probably not be working with other people like physically in the same room unless you're like brother and sister or something like that, if you want to do this together with a friend, like over the phone or over a chat or something like that, I encourage you to work together just like I would in class. This is like what we would be doing in class. I would give you a short little, this is what a vector is, and then here, go do some vector con stuff. All right, now we're going to go and learn some calculus based on this. This is just what I would ask you to do, but like compacted into a video online version. So feel free to use all of the things that I would normally let you do with Khan. Use a calculator if you want to. So good luck. Thank you.